In the previous video, you learned how to find the distance between any 2 points on the Cartesian plane and determine the midpoint of the segment joining these 2 points. Now, let's focus more on the steepness of a line. Consider these 2 staircases. Which one is steeper? Which one do you think has a greater slope? The slope of a line is a measure of its steepness. Some theorems in geometry can be proven analytically by using slope. In this video, you'll learn how to 1. Determine the slope of a line, and 2. Use the slope of a line to solve problems involving parallel perpendicular lines. The slope of a line, denoted as m, is the ratio of the change in y over the change in x. An easy way to remember this is rise over run. M is equal to rise over run and is also equal to vertical change over horizontal change. We can also obtain the slope using the following formula. Given any 2 points on the line, x1, y1, and x2, y2, m is equal to y2 minus y1 over x2 minus x1. Let's have some examples. Example 1. Determine the slope of the line passing through the points -5, 3, and 3, -7. Solution. Let x1, y1 be equal to -5, 3, and x2, y2 be equal to 3, -7. Substitute in the formula. M is equal to -7 minus 3 over 3 minus -5 is equal to -10 over 8, simplifying -5 over 4. We could also sketch a line using the slope as illustrated in the next example. Example 2. Sketch the line passing through point 4, -3, with a slope of 4, 3. Solution. Plot the given point 4, -3. From this point, use the slope to determine a second point. The numerator tells us how many units to move up or down, and the numerator tells how many units to move right or left. M is equal to 4 over 3 and is equal to rise over run. So, from the point 4, -3, move 4 units up and then 3 units to the right to obtain the point 7, 1. Then draw a line to connect the 2 points. You may verify that you have drawn the correct line by calculating its slope. M is equal to 1 minus -3 over 7 minus 4 and is equal to 4 over 3. Lines fall into one of 4 categories: rising, falling, horizontal, or vertical. 2 lines are parallel if and only if the slopes are equal. L1 is parallel to L2 since the slope of line 1 is equal to the slope of line 2. 2 non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. Line 1 is perpendicular to line 2 since the slope of line 1 is the negative reciprocal of the slope of line 2, or the product of the slopes of the 2 lines is equal to -1. Example 3. A line L has a slope of 4. What is the slope of a line parallel to L? What is the slope of a line perpendicular to L? Solution. Parallel lines have equal slope. The slope of a line parallel to L is also 4. Perpendicular lines have slopes that are negative reciprocals. Therefore, the slope of a line perpendicular to L is -1 over 4. How about a more challenging example? Example 4. If the line through point X, -3, and point 3, 1 is perpendicular to the line through point X, -3, and point -1, -2, find X. Solution. Since the lines are perpendicular, the slopes are negative reciprocals, or the product of the slopes is equal to -1. We can use the equation m1, m2 is equal to -1. First, let's determine the slope of each line. We denote m1 to be the slope of the line through point X, -3, and point 3, 1. Thus, m1 is equal to 1 minus negative 3 over 3 minus x is equal to 4 over 3 minus x. We denote m2 to be the slope of the line through point x, negative 3, and point negative 1, negative 2. Thus, m2 is equal to negative 2 minus negative 3 over negative 1 minus x is equal to 1 over negative 1 minus x. Substitute in the equation m1, m2 is equal to negative 1 to solve for x. 4 over 3 minus x times 1 over negative 1 minus x is equal to negative 1. Four is equal to 3 plus 2x minus x squared. X squared minus 2x plus 1 is equal to 0. X minus 1 squared is equal to 0. Thus, x is equal to 1. To verify our answer, we could sketch the graph. Notice that point 1, negative 3 is a common point of the two lines. This implies that the point of intersection of the two lines is point 1, negative 3.